If you want to run Keycloak as your identity provider in production, you're going to have to pair it with a production-ready database like Postgres. The default embedded database that Keycloak runs in a development or testing setup isn't going to be enough for a production workload. So in this video, I'll show you how you can connect Keycloak with your Postgres database. Here's my Docker Compose YAML file that runs my .NET API, which is configured to connect to my Keycloak instance, and I've also got an Aspire dashboard for observability. So first things first, we're going to actually need our database instance. So I'm going to define that as another service. Let's call it Postgres. The image I'm going to run is going to be Postgres 17. Let's also give it a container name. I'll call it the Keycloak database. And then let's give it a couple of environment variables. The first one is going to be the Postgres user, and I'll use the value of just Postgres. Let's also provide the Postgres password, and I'll just use a dummy password for testing purposes. And let's also initialize a database inside by passing in PostgresDB, and I'm going to call this database Keycloak auth. I'm going to define a volume mapping so that I can persist my data locally. And then finally, for the ports, I'm going to expose the default port, which is 5432 for Postgres. Now, before we continue with the Keycloak setup, I want to just run this to confirm that my Postgres instance is starting up. And if I open up Docker Desktop, I should be able to see my Postgres database up and running, and we can find it here. Now, one more thing I want to do before we connect this to our Keycloak instance is to connect to our database so that we can create our database schema first. And I want to use a dedicated schema to just isolate all the Keycloak tables, and this will make it easier to run Keycloak together with our regular tables from whatever application it is that you're building. So what I want to say here is create schema if not exists, and I'm going to call it Keycloak. Let's execute this. It completed successfully. I'm going to exit, and then let's go back to our Docker Compose YAML file. What do we need to tell Keycloak to connect to our Postgres instance? Well, one thing we can do is add a dependency between our Keycloak service and our Postgres service. We can also tell Keycloak to restart until it can successfully run and connect to our Postgres instance, and then everything else is going to be configuring the respective environment variables, and I'll walk you through what they are one by one. The first one is KCDB, where we define the type of database that we are connecting to. In this case, it's going to be just Postgres, and don't confuse this with the service name. This is just used to denote the specific DBMS used for persisting Keycloak data. It could be SQL Server, it could be Oracle, or any other database that Keycloak supports. Then we've got KCDB username and also password, which is just Postgres and Postgres. Then I can configure which schema we want to use, and we created this Keycloak schema just a moment ago. So that's where I'm telling Keycloak to store its data. Then I've got KCDB URL host, and this is just the host name for your Postgres instance. In my case, this is going to be Postgres, but this matches the service name that I've configured in my Docker Compose file. If this were called something different, like KeycloakDB, then this is my host name, and that is what I would use in the environment variable. Typically, this is going to be your URI for a hosted Postgres instance, let's say somewhere in the Azure or AWS cloud. Then you've got the KCDB port. We're running this with the default port of 5432. And finally, I've got KCDB URL database, and we've got a custom database where we are storing our data, which is called KeycloakDB, or actually I've made a mistake. It should be Keycloak auth. So let me update this. But essentially, this is the database within Postgres where we are going to persist our data. And that's everything you need to do to set up Keycloak to use your Postgres instance as its database. So now I should be able to just run this using Docker Compose. And if we go into the logs for our Keycloak instance, we should see it connecting to the Postgres instance. Now, because the database schema doesn't exist, Keycloak is going to go ahead and scaffold all of the database tables that it needs to run, and in a moment or two it should be ready to start accepting connections. So if I go to localhost 8080 and we type in our admin username and password, we should be able to log in to our master realm. So if I go to manage realms, there's the master realm here, but I can go ahead and create my custom realm that's configured for use inside of my codebase. So let me quickly set this up by enabling user registration and then creating a client that we can use to authenticate with Keycloak. I'll press next here and next. We have to configure our redirect URIs and the web origins. And now I should be able to go into my Swagger UI. From here, I can click Authorize, specify the name of my client. Let's select both of the scopes and then click Authorize. This should redirect us to our Keycloak realm where we can enter our username and password, or if we don't have it, we can register as a new user. And after I fill in the data, I can click register. We get redirected back to our Swagger UI, and we've also got our access token. Now I can send an authenticated request and you can see that we get back our data. So everything still works, but how are we so sure that we're actually using the Postgres database? The best way to know is to check. If we connect to our Postgres instance from some database viewer, we can find our Keycloak schema here. And inside of it, you can see we have 90 tables. So these are all tables created by Keycloak when we configured our connection to Postgres. And for example, the user entity table is what contains our user data. And here's our test user that we just created. And you can see it's connected to our custom realm. So a realm is a logical grouping that contains our users. We can also find our realm here in the respective realm table. So there's the default master realm and also our auth demo realm. Another interesting thing is the user's credentials, which you can find in the credential table. And if I scroll to the right, what I found interesting is how Keycloak stores the information for the hash function, but also the password data for the user. So there's the hash part in the value, and it also contains the salt, which was used to hash the password. Then in the credential data column, it stores the number of iterations used, the hashing algorithm, and you can see that Keycloak uses argon2 by default, and then a couple other configuration values. Now, if we take a look at the entire diagram of the Keycloak schema, you can begin to see just how complicated the data model is. So as I said, it's 90 tables just for authentication, and you can see the tables are grouped based on what they belong to, but at the core of the Keycloak data model is the realm, and then everything else is related to it. So we've got the realm table here with most of the data. Another big one is for the API clients that we have. Then here's the user entity table and everything else that's required to keep Keycloak up and running. And a reminder again that this is the recommended approach to run Keycloak in production, and you should not be using the embedded database that it comes with, which you're going to see in most of the Keycloak demos, including the ones I've previously published on my channel. This is the first time I'm showing how to actually use a proper database like Postgres for your Keycloak instance. And all you have to do is just set up a couple of environment variables to connect to your Postgres instance. And if you want to grab the source code for this video, it's going to be available for free in the pinned comment right below. If you care about security, you should not forget about two-factor authentication. And here's how you can implement this in ASP.NET Core using time-based one-time passwords. If you enjoyed this video, consider gently tapping the like button. Thanks a lot for watching, and until next time, stay awesome.